Welcome back you guys to Igcse Math Solution. In today's video, as you would have already seen, we'll be discussing about interest. So simple interest and compound interest, and you will see it is not so simple. Both of them, they have their intricacies and why one of them was used earlier and how the other one took over, and now we mostly only have compound interest. But let's see what the whole story was. So let's get started. We'll begin with the easier part of both of them, that is simple interest. So whenever you hear about those cruel money lender stories wherein the farmers, they did not have money and they will go to a money lender and he'll give them some amount, let me say A. Now in return he'll give them a period, suppose 1 year, and he'll say at the end of 1 year, I want my amount A back from you, plus I want some interest. Now this interest, this is actually my simple interest, because back in those days people were not so advanced in mathematics. Also the money lenders, they already had so much in their plate, they did not want more and they weren't so greedy, so they use simple interest. Now what is simple interest? The formula, if you see, simple interest is nothing but PNR the whole by 100. Here P is my principal amount. Next I have N. N is the time duration, or you can say the number of terms for which I have been issued the money. Let me just write it as time. And R finally is the rate of interest. So simple interest is quite simple. If you see, you just have three terms, which is P and R by 100. And to calculate the amount payable, I write it as A. A is the amount payable, that is at the end of the time duration that I have taken the money, what is the amount that I have to pay. So that will be the principal plus the interest. So I can write it amount as principal plus my interest. So that will be P plus PNR by 100. Here R is actually rate in the form of percentage. That is why we have this division by 100, because we have taken R as a percent. It is 2%, 4%, or that way. Finally I can simplify this. I can take P as common and 1 plus NR by 100. So this will be the amount payable if I have been calculating simple interest. Now if you try to construct a timeline to see when which type of interest was used, so on this huge timeline we have, this is around 15th century, then here you have the 20th century, this is the 21st century, and these dates in between. So simple interest actually dates back to before even we started using the regular Gregorian calendar which we are using today, around 3000 years or more, don't quote me on that, but more or less 3 to 4000 years before, we have some Egyptian scriptures wherein you can see the simple interest is being used. And compound interest, it started somewhere in the 17th century. So I think in Italy it was first used. In the compound interest, we have seen and we have somewhat evidence that it was started in 17th century. But because you see simple interest, it has been in use since so long, because it was quite simple and easy to use. So whenever a person comes to a money lender, he'll ask for a sum and he'll ask for $1,000. So the money lender, he'll be like, I want some interest on this sum that you're asking. I'll give you the $1,000 plus I want 10% in interest on that. Money lenders in those days, they demanded whatever they liked. Now we have governments and banks which are regulated, so if he asks for 10% and he'll give you a period of say 1 year, you have $1,000, you'll have to repay that principal plus the 10% at the end of 1 year. Now you make use of that $1,000 or whatever you do. At the end of 1 year, what you have to pay, amount payable, will be the principal plus it will be the interest. In this case it will be the simple interest, because in those medieval times simple interest was the thing in use. So you have 1,000 plus your simple interest. What will be 10% of $1,000? If you have 1,000 and you want to find out the 10%, convert this percentage into a fraction. That will be 10 divided by 100. To convert a percentage to fraction, you just divide it by 100. Now you can cancel out some zeros which you can see common. So my interest is $100. Now after the era of simple interest, now it is this time for compound interest. Why did we use compound interest? We had simple interest for our use and it was more or less serving the purpose. Why did you need a different type of interest? Well, when banks came into the picture, people were given more importance. The money, it was more about investing. You keep your money, you give it to the bank and you take the interest. The bank will use it for their purpose, but at the end of the period you can remove your money plus you will get an interest on that. Now people notice that simple interest, again taking the same example which I just said, if I have $1,000, I keep it in my bank, the bank says I'll give you 10% interest on that. So at the end of 1 year, at the end of second year, what do I get? Again I'll be getting 1,200. Why is that? Because again my simple interest says 10% is my interest, so my interest remains constant. So my interest will be $100 for each year that I keep my money in the bank. So my principal was $1,000. If I keep it for 1 year, I am supposed to get $1,100. If I keep it for 2 years, I am liable to get 1,200. If I keep it for 3 years, I'll get 1,300 and so on. But you see, if someone is smart enough and he figured out this is what the basis of compound interest is. He saw that at the end of the first year, if I remove my money and again I invest it in the same bank, like instead of keeping it in the same cycle, because each time I'm only getting $100. So let me just break this chain. After I get 1 year worth of my interest, I'll remove it from the bank and I'll create a new deposit, as in I'll give it again to the bank, but this time I'll be saying my principal is 1,100. Now because this is my new principal, what will be my new simple interest? See, we are still calculating simple interest. So what will be my simple interest on this? The bank had said 10%, so according to that I should be getting $110 of interest. So after 1 year I had 1,100. If I would have kept it in the same bank as simple interest, they would offer me 1,200 at the end of 2 years. But I changed it into a new account, and according to the new account I should be getting my principal plus my interest, which is 110. So my total will be 1210. If you see, here I was getting only 1,200, but in this new account, which is actually using the basis of compound interest, I am getting $1,210. This extra $10 is what we are looking for. When you look at a bigger scale, if you keep your money for a few 10 years or 20 years, this $10 will be so enormous, so huge that you'll be baffled to see this. This is why Albert Einstein stated that compound interest, it is actually the eighth wonder. Eighth wonder, guys. Why did he call it so? Eighth wonder? Because this is exponential growth. Compound interest it works on exponential growth. What is exponential growth now? If I make two charts, this is for my simple interest. My interest remains the same throughout for how much ever period I keep it. So my principal is something, and each year I'll be getting the same linear fashion. My amount does not change so much, but if I have compound interest, my growth will be exponential. The longer I keep it in the bank, the more and more money I'll be getting. That is when the banks understood that people have become smart enough. They are keeping their money just for 1 year. At the end of 1 year, they remove it and again bring it into a new account, and then they are making use of something which is actually compound interest. So the even banks shifted from using simple interest to compound interest. Now let's move to the formula for compound interest. Compound interest, if you would have noticed till now, what is it? My amount is actually my principal which I invest in the first place. Then for the first year, let me call this A1. My A1 is the amount which I should be getting at the end of first year. I'll be getting my principal plus I'll be getting the interest. Now this time it is actually just the simple interest because I have put the money into the bank and it is just for 1 year. So what will be my interest? It will be PR by 100. Now this is what I'll be getting at the end of first year. I can write this as P times 1 plus R by 100. Next I'll take A2. A2 is the amount which I should be getting at the end of 2 years. So at the end of 2 years, now my A1 actually becomes my principal. Now this is the money which, if you don't want to get into what is compound interest, you can think of it as this becomes my new principal and I have again put it into an account which will give me simple interest, but my principal is changing. Each year my principal is changing. So now for A2 my principal will actually be A1 itself plus A1 times R by 100. So if you simplify, you get A1 times 1 plus R by 100, which is nothing but P times 1 plus R by 100 the whole squared. You see, A1 is P times 1 plus R by 100, and for A2 you have another term, the same term, so you get squared. Similarly, if you calculate A3 will be nothing but A2 plus A2 times R by 100, which will again turn out to be P times 1 plus R by 100 the whole raised to 3. If you see, you can notice a pattern. Now AN is nothing but the amount which I'll get after n years or n terms. It will be P times 1 plus R by 100 the whole raised to n. So this is the direct formula to calculate compound interest. Again, P, N and R are the same what we have discussed earlier. It is principal, time period and rate of interest. And again, R was given in percentage. So to convert it into a fraction, we have divided by 100. If you have your rate of interest in fraction form itself, you can just input that instead of dividing it by 100 again. So you see, you have this formula. You can use it anywhere in your Igcse syllabus because you have to know this for your math exams. So you can use it anywhere you want and without giving them a proof that how did you actually come up with this. Next we'll see one more topic. It is actually compound interest only, but it is a small variation. Till now what we have talked about, our time period was actually 1 year, as in it was compounding annually. My amount, whatever I get, I calculate that what is my amount after 1 year. What if I want to calculate what will I get at half year? As in, the bank till now had told me I'll give you an interest rate of R and I'll compound your money annually. There are other ways as well. Some banks will say I'll compound your money half yearly. Here if you draw a timeline, this will represent 1 year and my rate of interest will be R. But if it is compounded half yearly, you will have a rate of interest R by 2 for the first half. For the second half, your interest rate will be R by 2 again. If you still don't get the point, well, your formula will change by a small bit. I'll take the case for n times a year, as in your money is compounded n times. So your amount will actually turn out to be P times 1 plus R by T upon 100 the whole raised to n times T. Now n is my number of years, T is the times it is compounded. If it is compounded half yearly, then T will be 2. If it is compounded 3 times in a year, then my T will be 3, or it can be any number. Whatever they say, they compound it annually, then it is just 1. If they compound it quarterly, then it will be 4 as well. So this was a quite small variation. They normally won't test you so deeply in compound interest, but sometimes they might give you this formula. So if you have an idea, it will be great. With this, we come to an end to today's video. If you have any queries or are still confused, you can put your queries down in the comments, or you can mail me. And do remember to share this video, like it, or if you did not like it, then please dislike it. Do press one of those buttons and subscribe to my channel, ring the notification icon, and follow me on Instagram, Twitter and Facebook. If you have anything, you can definitely send it to me or share it to me on the social media platforms, and I'll definitely try to get back to you. Thank you for watching.